In continuity with my previous two videos, in this video we are going to do electron dot structure of alkanes, alkenes, and alkynes. That means we are going to do electron dot structure of hydrocarbons, and the homologous series for which we are doing is alkane, alkene, and alkyne. Now let's begin with writing its molecular formula and then doing the dot structure. First we'll do bond structure and then the dot structure. Let's say I choose first methane. Methane, as you can see, the general formula is CnH2n. So that means placing carbon as one. Right, meth stands for one carbon atom. Placing N as one, we are getting CH4. Now, first I'll do the bond structure where one carbon atom is one carbon atom is bonding with four hydrogen atom with single covalent bond. And this is what the bond structure. Now, in order to make a dot structure, I suggest, even if they ask you for a dot structure, make a bond structure first. And then what you can do here is to replace this bond, right? We can replace this one single bond with a cross and a dot, right? This way you can replace all of them and you check here. So what you can understand from here that this hydrogen needs two electrons, this hydrogen, and this hydrogen. And the carbon needs 8 electrons and it gets 8 electrons. So this is what the structure of methane, that is CH4. Next, once we have done methane, now I can say if I do the next ethane, right? I'm going to do ethane here, placing NS2. This is C2H 2 plus 2 4 plus 2 6. Now I'll write ethane here. As you can see, ethane has two carbon atom and there is a single bond between carbon atom, that is, as it is an alkane. And as you can see, there are 6 hydrogen. This carbon is attached with. Now, as I said, even if they ask you for a dot structure, electron dot structure, make a bond structure and use this to make a dot structure. Right. So now I'm going to make its a dot structure. Let's say I copied it, and once I copied it, I'm going to replace this. Right. Each bond. Okay, let's do one by one, right? So what I'm going to do is to replace this bond with a cross and a dot. Same I'm going to do with all carbon hydrogen bond. This is cross dot, cross dot, cross dot, cross dot, and a cross dot. And between carbon bond, I'll be using cross, indicating that here dot represent the electron for hydrogen and cross representing electron for carbon. Now you can see that all hydrogen got satisfied with 2 electrons, as it needs 2 electrons in the outermost shell to attain the inert gas configuration, and for carbon it is 8. So this way we did for what I did for ethane, sorry. Now if I check for, let's say I do this one, as you can see that here for ethene, if I replace N with 2 here, C2, and this is H4. Now, you should know that it should have one or more double bond between carbon atom. So first I'll write 2 carbon atom and joining with a double bond between carbon atom. As you know, alkenes have double bond, one or more double bond between carbon atom. Now remaining, what I'm going to do is to, as you can see that this carbon has unsatisfied valency, as its valency is 4, so 2 is there. 2 bond is there. I'll attach 2 more hydrogen on this side and 2 more hydrogen on this side to make a dot structure over here. So what I'll do here, I'll replace this carbon hydrogen bond, this carbon and hydrogen bond, with a cross and a dot. and carbon-carbon bond. Now figure out here, one bond is represented by a cross and a dot, and there is a double bond. So I'll place it with cross cross. Now check here, this hydrogen got 2 electrons, and the first carbon, as you can see, this is 2 plus 2 4, 4 plus 4 8. The other carbon 4 plus 2 plus 2 8. So this is how the structure of ethene is formed, the bond and as well as a dot structure. If I go for the next one, next I'll go say, I'll choose this one as butene. So it's C4 placing NS4 here, we get H8. Now first I will join 4 carbon atom with a single bond, and then as you can see it can have one or more double bond. But for class 10th syllabus, you should remember that for butane you will place a double bond between the last 2 carbon atom. Now we are going to place hydrogen here. As you can see, there are 8 hydrogen. It has 3 unsatisfied valencies, 1 2 3. Each carbon has valency as 4, tetravalency. This carbon already have 2 bonds, so there is a space for 2 more bonds. This carbon has 3 bonds, so there is a space for 1 hydrogen. This carbon has 2 bonds, so it has space for 2 hydrogen. So I made the bond structure, and I'm going to use this bond structure to make a dot structure. So for a hydrogen carbon, I'm going to replace this bond with a cross and a dot. This is a cross dot representing cross as the electron of carbon. All right, and there are more, these 2 hydrogen replacing with cross and dot. As I said, for carbon-carbon, I'm going to use cross-cross. For this carbon again is cross-cross. A pair of electrons representing a bond. So there is 2 bond. So I'll be representing by 4 crosses. Now for hydrogen, you can figure out that these hydrogens get satisfied by sharing 2 electrons, now attaining the noble gas configuration of helium. For carbon, you can see the first carbon will have 2 plus 2 plus 2, 8 electrons. The other carbon has 2 plus 2 plus 2, 8 electrons. The third carbon atom has 2 plus 2 plus 4, and the fourth one has 4 plus 2 plus 2. Right. So this is how the electron dot structure of butene is formed. Now I'll go for, say, ethyne here. Now, as you know that in this case, the general formula is CnH2n minus 2. So if I place N as 2, what I'm going to get hydrogen as 2 again. So first I will, let me erase this part first. Now check. If I place how many carbon? There are 2 carbon. And as you can see that an alkenes molecule have a triple bond between carbon-carbon atom. So that's one or more triple bond. I placed, there is only a pair of carbon, so I placed it. Now as you can see, 2 hydrogen atom, this carbon has 3 bond already. So we'll say it has a slot for 1 and 1 for this. Now replacing this with a bond structure, same trick is what we are going to apply. For example, if I keep a copy of this below, and I'm going to replace a bond between carbon hydrogen, the cross dot, same here with a cross dot, and between carbon carbon, as you know that one bond representing a pair of electrons, there are 3 bonds, so there should be 3 pair, and since it is between carbon carbon, I'll place 3 pair of crosses. Now check here, this hydrogen needs 2 electrons, this hydrogen needs 2 electrons. The carbon, the first carbon has 2 plus 6, that is 8. The second carbon has 6 plus 2, that is 8. So this is how the structure of electron dot structure of ethene. Now let's say if I take one more, which one I can take? Let's say I take propyne only. So placing NS3, hydrogen is how much? 3 into 2, 6, 6 minus 2, that is 4. So first I'll place 3 carbon atom, and realizing that it should have a triple bond between carbon-carbon atom, I'll place triple bond with the last carbon atom. Keeping in mind that it has only one unsatisfied valencies, as you can see that it has a 4 valency, there is 4 bond and it's a slot of 1 space. Now to talk about this carbon atom, you can see that it's already have a 4 bonds, so we can attach 3 more hydrogen here. Now what we are going to do in the structure, we can take the help of this bond structure to draw its dot structure. So now check here, these hydrogen and carbon. Wait a second. All right. So I'll be replacing this single bond between carbon hydrogen with a cross and a dot, representing cross for electron of carbon and dot for hydrogen. For this one, as you can see, between carbon-carbon, there is a single bond. So this is cross and cross. And over here, there's a triple bond. As you know that one pair of electrons represent a bond and there's triple bond. So therefore, it is 3 pair. Now this hydrogen has 2 electrons, 2 electrons, 2 electrons, 2 electrons. This carbon has 2 plus 2, 4, 4 plus 2, 8. This the other carbon has 2 plus 6, that is 8. And the last carbon has 6 plus 2, 8. And that's how this is placed. Similarly, you can practice these diagrams